Hi, and welcome to this video on quadratic patterns, part 3, brought to you by the Answer series. In this video, the focus is going to be on the relationship between a quadratic pattern and its first differences. I want you to pause the video, try to fill in the blanks on your own, and then we will go through them together. The essence of this explanation lies in the fact that each and every term in the quadratic pattern can be generated by us taking the value of the first term and simply adding on differences until we reach our goal. So if our goal is to generate the seventh term, which has a value of 49, we are going to add the preceding differences, and what we're focusing on is the number of differences. So notice that there are 6 differences which need to be added to the first term to get the value of 49. This means that if we are working out the 10th term, we will add 9 first differences. We can also see in this pattern, and we should know that in any quadratic pattern, the first differences row will always be a linear pattern. The formula that we are going to be working with here is that the nth term in a quadratic pattern can be generated by adding the first term and n minus 1 first differences. This is becoming very important in exams, so take your time and have another look at this if you haven't fully understood the explanation. In this example, which is the only example we're working through in this video, there are several familiar questions which we will work through fairly quickly, and then we will focus on the last few questions which are slightly different. Pause the video, try all the questions on your own, and then we will go through the solutions together. To start with, we are simply asked to find the formula for the quadratic pattern. So we're going to write out the row of first and second differences. Then we're going to equate 2a to 1 and work out a equals a half. Using that result and equating 3a plus b with a half, which is the value of the first difference, we work out that b is minus 1. Finally, using a equal to half, b equal to minus 1, and c, adding up to the value of the first term in the pattern, we work out that c is minus 2. So we can get the answer of the formula fairly quickly. That is not the correct form though, so you need to take out the half as a common factor, and then the bracket values are simply double the values you started with, because the half is going to halve them when it's simplified out. In question 1.2, we need to find a formula for the row of first differences. So we're going to write out the first differences and then simply create a formula. We can see that the gaps between those first differences consistently produce a value of 1. So our formula is Tn equals 1n plus b. The value of the first term is a half, so a half is equal to 1 plus b, and b is equal to minus a half. So we have the formula Tn equals n minus a half. We can use that formula to work out the value of the 50th first difference by simply substituting 50 into the position of n. So our value will be 99 over 2. If you prefer, 49,5. The next question asks us which term has a value of 111 over 2. We equate the formula n minus a half with 111 over 2 and work out that n is 56. To answer that correctly, you need to make the last statement and say the 56th term has a value of 111 over 2. In order to work out the difference between the 65th term and the 64th term in the quadratic pattern, we need to properly understand the difference in the positions. What I mean by that is the 65th term minus the 64th term is in fact the 64th first difference. If we look at the note on the right, when you take Tn and subtract Tn minus 1, you are working out the n minus 1th first difference. So in summary, if we take the second term and subtract the first term, we are getting the the first difference in the first difference row. If we take the third term and subtract the second term, we are getting the second first difference. And one more time, if we take the fourth term and subtract the third term, we are getting the third first difference. When we take the 65th term and subtract the 64th term, we are getting the 64th first difference. We worked out earlier that we can create a formula for the first differences using n minus a half. So we simply substitute 64, subtract the half, and we will get 127 over 2. It's always good to have a backup plan in case you suddenly find yourself confused. So a longer but safer method, because there's no confusion around the meaning of the value n. You can choose to take 65 to the original formula for the terms in the quadratic pattern. If you substitute 65, the value of the 65th term is 4091 over 2. You go back again, this time with 64. Substituting 64 into the quadratic pattern formula produces a result of 1982. Subtracting those two answers will produce the result you need of 127 over 2. You need to choose the method that you're going to use based on your understanding of the difference between n in the original pattern and n in the first differences pattern. The last question we are going to answer in two very different ways. We are being asked here to calculate the number of terms in the quadratic sequence if the sum of the first n first differences is equal to 3481 over 2. We're going to start by using the formula that we derived in the first slide. So if we want to work out the nth term, we can add the first term value and the sum of all the differences preceding the term that we are looking for. So to work out the position of this term, we're going to take the value of the first term and add all the differences that we've been given. So we simply set up an equation, put the equation into standard form, factorize if possible, otherwise use the quadratic formula. When we get our answers, which are 60 or minus 58, we put a line through the minus 58 because we cannot accept a negative value. So we accept 60 only, and we can state that there are 60 terms in the quadratic sequence because the n we are using is the position of the term that we are looking for. The second method is a little confusing, but is a very good method, so you need to process this properly. Firstly, I want to remind you that if you add odd numbers, there's a very, very simple formula for that result. So obviously 1 equals 1. If you add 1 and 3, you get 4, which is simply 2 squared. If you add 3 odd numbers, you get 9, which is 3 squared. If you add these odd numbers, there are 5 of them, you get 25, which is 5 squared. So if you were to add n odd numbers, which is represented in this last row, the formula would be n squared. If we take our row of first differences and show the details here, these numbers are all adding up to the sum that they've given us, because they've told us that the first differences add up to 3481 over 2. Doubling both sides gives us on the left the row of odd numbers, first n odd numbers, and on the right 3481. So n squared is equated to 3481, and that produces two answers. Any quadratic pattern should produce two results when you're looking for the position. You need to find both and then actively discard the one that is not appropriate. By selecting n equals 59 only, I have discarded the option of n being negative 59. When we know that there are 59 first differences, we don't have the answer. We know that those 59 first differences will be added to the first term to find the next term in the pattern. So there are, in fact, 60 terms in this quadratic pattern. You really need to process the relationship between the first differences and the number of terms in a pattern in order to answer some of the questions that relate the quadratic pattern to its first differences. This is confusing. I suggest that you go through this question and the previous question again in your own time. And I hope that when you tackle questions like this in the future, you will find them both manageable and enjoyable.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.